This is the bottom of the engine, the crankcase and cooling jacket with their power piston and displacer. The way this is set up, right now there's a Marathon generator in here, 25 kilowatt, and this one has a small gearbox and 2 flywheels in the generator housing. There's a rhombic drive inside here, and what that is 2 crankshafts that move in opposite directions like this with 0 vibration. So what that does is it allows a single cylinder engine to have 0 vibration when it's running. Because normally an engine would vibrate, this one doesn't have any vibration when it's running. Wow. So that's an advantage, and it keeps the noise down too. So the 2 pistons, the power piston runs down in here. It's got a graphite diamond coating, and here's one of the pistons with the coating on it. They're titanium pistons. We've got a titanium nitride undercoat, which is ceramic undercoat, and then we put this graphite diamond plasma on the outside.
Can I touch it?
Yeah. It's the same friction as Teflon in air, but in an inert atmosphere, it's 1/1000th the friction of Teflon. So it's almost 0. This was developed for the fuel pump industry for automobiles, because diesels were taking the sulfur out of the fuel, and the sulfur acts as a lubricant inside the fuel pump, and so they had to come up with something else, and that's where Argonne Lab came up with this. We found out about it several years ago and integrated it with our engine, and so we can run without lubricants on the...
So that has the diamonds in it?
It's a graphite diamond hybrid, actually, plasma coating.
Wow.
It's very low cost, but very low friction.
Wow,
so
impressive.
Argonne Lab did a 5-year test of the coating, and only 20% of the coating, and it's microscopically thin, but only 20% wore away after 5 years. So we're anticipating better than a 20-year life with no maintenance on the...
And that was with continuous operation?
Continuous operation, yeah.
Holy smokes.
It's amazing stuff.
Wow.
So what we're doing, we're integrating some of the best features that we get out of the federal labs into the engine. There's no sense reinventing things that people have already done. This is an example. And another example is this is a polyphase generator. So this little generator, 3 inches long, replaces a 2-foot generator in here. So eventually we'll have 2 of these inside the engine, 12.5 kilowatts, and that'll give us our 25 kilowatts for the engine.
Wow.
This is developed by Light Engineering. Amazing technology.
So what we have to establish is that this is not voodoo science. It's not, what do you want to call it?
You're not violating any law.
You're not out there. You're not into this voodoo where people have not been able to make it work. This engine has been in production for years and years, different various ways.
There's hundreds of these engines in the world.
What you're doing is not what's new about it is the fact that
efficiency, less maintenance, and lower cost through mass production techniques. So it's really mainstream. Our biggest patent was our dual shell patent. I'll show you that over here. The hot part of the engine is made out of Haynes 230. We've got heater head tubes on the inside. The heater head tubes are actually, we manufacture these ourselves. We came up with a process in-house for putting this together. So it's actually a heat transfer, and if you look at it, there's a bunch of little tubes inside, little plenums. You asked how you get the heat to go in and out so rapidly. So an early version, we tried bending them, and you can see the plenums. So what we came up with, one of the things that we invented was how do we came up with a process to weld these little flanges into the tube through an automated process. So I showed this to a metallurgist 5 years ago, and he said only big corporations do this. It took us 3 months. So it gives you an idea of the technology that we're able to produce and integrate into our engine.
Wow.
So we went to straight tubes, and now we have tubes in the engine. The burner and the TZM piece is here.
Oh, wait.
Yeah, go ahead.
Yeah, okay.
So we put a burner inside there. We're currently running with liquid silver within here. What happens is the liquid silver's at about 2,000 degrees, and we're heating it from the inside here with the burner, and the heat radially transports out. The silver just sits there and convects automatically within this and helps transfer the heat to the tubes. So the helium's going through those tubes about 30 times a second. So very rapid. The air preheater fits on top of the dual shell, and we have a burner that fits down in here. So like here's a burner component. It's a swirl burner, and this was actually developed by one of our investors 5 years ago. And so this is another example of taking technology that someone else has already developed, and the swirl burner is a state-of-the-art burner for high efficiency combustion. So we had one of our retired investors design this for us. It worked perfect right out of the box, and so we're able to run with it. Here's an early version of it. It's what we did is integrate a fuel system into it, so we can put natural gas fuel in. It preheats the fuel, goes out through these little injector tubes. The air comes in and swirls, and you're getting swirl combustion occurring within a nozzle. That goes down the chimney into the heater head, and that's how we transfer the heat out into.
Because of the swirl concept, it completes the combustion, where
Yes.
otherwise it would take too much time to.
Yes, we get
Okay.
rapid mixing.
Okay.
Yes, so.
I do it in my layman terms.
Absolutely, that's all, really, it's just a matter of getting a good mixture of the fuel air so that you get good rapid combustion. This is our second generation air preheater. It's got foil cartridges, and the air basically goes back and forth through this folded metal cartridge, and so that the air comes in, gets heated by the exhaust, and then up to over 1,000 degrees, and then it comes back, and then it burns, and then it gets cooled back down to almost room temperature when it comes out. So we can recover 90% of the exhaust energy with an air preheater. So what we did is we set up a rapid prototyping lab here at the shop 13 years ago, and we bought NC machines so that we could fabricate our own parts. That is more rapid as far as being able to get the parts built, but also you understand the cost better when you build it yourself. So
These
our computer
monster
controlled-
machines build parts.
Yeah, this is a computer-controlled mill, and the other's computer-controlled lathe. So,
Can we open the doors and see inside that? Just for.
so
Oh wow. Okay.
you basically program the computer, and it controls the movement of the cutters. And also, we've got a rotary table on this one, so that we can do things like drill hole patterns in the cylinder walls and that sort of thing. So
And you created those little
parts,
plenum things, or you said with this?
Yeah, with all this,
Unbelievable.
with the lathes and mills. So we can make parts that are very small, or we can make large parts. Like this is a 1/2 inch thick. This is the pressure vessel for the dual shell. So this was hydro tested to about 2,000 psi. So we're very safety oriented. We check parts before we do them. We follow pressure codes so that everything's safe, and before we put gases inside.